So we're going to move on to objective 2, and this is where we speak about homeostasis. We're going to talk about homeostasis and explain its significance to the function of the body. Okay. And again, this is a big theme that will pretty much last throughout the rest of the course. Homeostasis is one of those fundamental, foundational concepts of how the body strives to be in sync, in balance in terms of most of the parameters. So when we think about the body, how does it manage to keep body temperature, blood pH, blood volume relatively constant day after day after day after day after day for the entirety of your life? How does your body actually maintain normalcy with these parameters? And that is what we define as homeostasis. So it's the ability of the body to maintain a relatively constant internal environment. And I like to add to this definition, in the face of changing external environment, right? So in the face of a changing external environment, the body manages to maintain a relatively constant internal environment. Some of the components of the internal environment that are regulated, that are maintained, are our body temperature. At around 37 degrees Celsius, we've got our body blood volume, which kind of makes up our blood pressure, which should be at around 130, 120 or so over 80 or 90. And then our body composition. So if you think about the breakdown of your body, so the amount of water that we said is pretty consistent, the amount of fat, the amount of protein or muscle, the amount of bone, how does the body maintain those things in a regulated way? How does it keep pH balanced? And this is what homeostasis is. So there are certain systems in our body that require different organs to play together, what we call systems integration. So the brain has to communicate to the heart, has to communicate to our blood vessels, et cetera, and keep things in a relatively constant state of balance. If we disrupt homeostasis, this is the initial basis for all disease processes and then eventually for death, okay? And we'll talk about several examples, but that is the main crux of understanding homeostasis. So this image here is really nice at kind of illustrating this concept, because on the left, we see this rock in its state of balance, what we would call its state of homeostasis. And then we can see that maybe a wave came and kind of knocked it over. And then this middle image is exactly what the body is always doing. It's always fine-tuning. It's always readjusting. It's always shifting. And so this middle picture is really what describes homeostasis, not necessarily the picture on the left, because our body does not stay constant in the sense that things don't change, right? Our body temperature changes if we go into a cold environment. Our body temperature changes if we go into a hot environment. If we're in the sun for a very long time, our blood pressure can rise. If we're exerting ourselves, so physical activity, blood pressure can also rise. So it's not that things are staying constant the way that we see them on the left, but it's that the body is always doing this thing in the middle, right? Continually detecting, readjusting, recalibrating, and bringing things back to this picture on the left, okay? Now, if we get to this picture on the right, this is where we start to introduce the basis for disease, such as diabetes, such as hypertension, high cholesterol, if we throw things out of balance and then they don't get back to this picture on the left, okay? So this is why homeostasis is so important. It's really the basis for maintaining general health or general well-being. Ready? Okay. So we are going to look at a scenario here, an example. We're going to draw an example here. And again, it's really important that you draw along with me as we illustrate this first example here, okay? Before we get into that, are there any questions? Make sure that if you've got questions, feel free to drop them in the chat. Myself and Ali will kind of be looking at the chat to see if there are any burning questions. Okay, So okay, so we're describing homeostasis here to start. And the scenario we're going to look at is a car. So we're going to talk about a car that is trying to ascend a hill, okay? And this is a very simplistic illustration of the concept of homeostasis, as well as the players that are involved in homeostasis. So our car starts off at the bottom of the hill here on the left. And please excuse my car. It's kind of scratchy. There we go. So that's our car. Let's give him a window. And it starts off going at a rate of about 60 miles per hour. Okay, so that's the initial rate that we start off at. And because we're going to put on our cruise control, we're going to kind of dial in that 60 miles per hour as our set point. Okay, and so when we speak about set point, this is the mileage or the rate that the car is going to strive to maintain no matter what. So we're going to call this our set point. Now, as this car starts to ascend the hill, so it's going to get to the foot of the hill pretty much, and then gravity is going to take place. The effect of ascending that hill is going to kind of kick in, and the car is going to naturally decline in its speed, okay? And because it's going to decline in its speed, that is going to set off what we call an error signal. So we see here a decline in speed. The car is now going at about 55 miles per hour. And because that is not our set point, this is the miles per hour that we want to maintain, that we're going to strive to maintain, that automatically sets off what we call an error signal. Okay, because of this reduction in speed. Now, as a part of correcting this error signal, the next thing that's going to happen is the car is going to naturally, as a reaction, increase the gas flow to the engine. So here's our car again. And this time, because we've increased the gas flow to the engine, we've slightly sped up the car. So the car is now going, let's make a note of that. We increase the gas flow. To the engine. And that's going to result in an increase in speed. So because of that now, the car is now going at about 58 miles per hour. And because we're now starting to increase our speed, we're getting closer to our 60 miles per hour, then we're going to see a slight reduction in the error signal. So we see a slight reduction in the error signal here. And then eventually, as we get to the top of this hill, we see that our car now gets back to that 60 miles per hour speed rate, and our error signal is now turned off. So we're back to 60 miles per hour, and then here we see we're back to set point, so the error signal is turned off. Okay? So it's important to establish two things, that the Set point is pretty much our basis, it's our normal. Anytime there's a deviation from the set point, that sends off an error signal. And the error signal is the trigger to get us back to our set point. So the error signal is going to be equivalent, the degree of the error signal is going to be equivalent to the difference between where we are and our set point, okay? So let's kind of try to represent this on a graph down here. Oops. So on the y-axis of our graph, we can put speed. That's in miles per hour. And then we're going to compare that to time. Okay. And let's kind of mark out our set point here on our graph. So that's where things are starting off. So that's about 60 miles per hour. And this is where we start off. So let's get, so this is our set point. At this point, we see a drop in the speed to about 55. And then we see a gradual increase until we get back up to 60, which is our set point once again. So what we really want to illustrate here is that as soon as we drop from our set point, we've got this error signal, and the error signal is going to be the degree to which we are away from our set point. So this is the difference here. And as we can see, this difference gets smaller and smaller until eventually the error signal is turned off. Okay, so here we've got the error signal on. And then down here, we turn off the error signal. Okay, so the important things I want to point out here is one, our set point, the fact that this is our baseline variable. Oops. And that is where we really want to maintain. So in the example here of our car, that's the speed our car wants to maintain in the face of any external changes. So even if we encounter a hill or a valley or a bump, we still want to strive to maintain that 60 miles per hour. And so anytime we deviate from that 60 miles per hour, there's going to be a signal sent off. We call that the error signal. And that's going to trigger a sequence of events in this scenario that is increasing gas flow to the engine. But understand that that could also be decreasing gas flow to the engine if we happen to speed above our set point, okay? And so that trigger is now going to bring us back to our set point. And as we get closer to our set point, the error signal becomes smaller and smaller and smaller until it eventually goes away. Okay.